Okay, I kind of felt like there should have been some problems like this on your review. So that's what this video is. If I were you, I would like pause it, maybe work the problem, and then, check your answer with me. Maybe you don't need to listen to my explanation. You could just fast forward to the answer. But instead of just working through it with me as I scroll, since you don't have these problems, if you would just pause it and get the problem written down and work it out, and then you can check to make sure that you can do this as well, because this is on the test and it is not on your review. Okay, so we're going to verify algebraically if the graph has x-axis, y-axis symmetry, origin symmetry, or none. So we can tell by looking that we think it probably has x-axis symmetry. That's what it looks like. So to test that, we won't have to test them all since we can narrow that down. Clearly it doesn't have the other. If we're going to test x-axis symmetry, then that means for every xy, right, that all these x's, the x value stays the same, but in a reflection on the x-axis, the y value changes. So that's what we would end up with. So that's what we substitute in to this. So here's our original equation. And I'm going to substitute a negative y in and leave x alone. So I'm going to get negative y, then I'm going to square it, minus x stays x, minus 4 equals 0. So negative y squared is y squared, minus x minus 4 equals 0. So this is what I get after my substitution. It does match this right here, so that is a yes. So I can say x-axis symmetry because for every xy, there is x negative y. Okay. So now look at the next one. All right. So again, pause if you want to try it on your own first. Sure looks like y-axis symmetry. So if it has y-axis symmetry, then xy would map to, this is when our x values change, but our y values stay the same, so negative xy. So I take that, this is my original, I'm going to plug in y for y. I am going to plug in negative x for x. Okay, so y is just y. Negative x to the fourth is x to the fourth minus 1. So here's what I end up with. It does match my original one. So this does have y-axis symmetry because for every xy, there is negative xy. Here's the next one. Now this one doesn't have a graph. So let's talk about what we have to do here. We're going to write it down. You don't get to go graph it on the calculator and cheat. Since you don't know what it looks like, maybe you do, probably don't, then we are going to have to check each one of them. So I'll start with x-axis symmetry. Okay? So if it has x-axis symmetry, then for xy would map to x negative y. All right, so x stays the same. I plug in my negative y. So negative y equals x to the fourth plus 1 over 2x to the fifth. All right, so I got to solve for y to make it look like that. So I multiply through by a negative 1, and y equals negative x to the fourth plus 1, there you go, over 2x to the fifth. So here, this, whether I distribute that in or put it in the denominator, it's not going to be the same as this. So these two are my original one, and when I replace it with this, that is not happening, so there is no x-axis symmetry. And there's kind of my proof of y. So then we'll move on to y-axis. So for y-axis, if xy, xy would map to negative x, y. So I plug that in. Y stays y. That's equal to negative x to the fourth plus 1 over 2 times negative x to the fifth. So this gives me y equals x to the fourth plus 1 over negative 2x to the fifth. So I've solved for y. That negative there isn't going to work itself out any which way, so these are not the same, so there is no y-axis symmetry. So that doesn't guarantee me origin symmetry, because maybe it doesn't have any symmetry. But if it does have origin symmetry, then xy would map to negative x, negative y. So now we'll try this one. So I've replaced the x and y with a negative, so negative y equals negative x to the fourth plus 1 over 2x to the fifth. So this gives me negative y equals x to the fourth plus 1 over 2. Oh, shoot. Back that up. That's supposed to be negative x to the fifth. I didn't plug that one in. So negative x to the fifth is negative x to the fifth, so this becomes negative 2x to the fifth. All right, so now if I solve for y, I can multiply both sides by a negative 1, so y equals, now remember, when you multiply a fraction, you can put the negative sign out front, but you can also either attach it to the numerator or the denominator. It's not both, because if I multiply by negative 1 over negative 1, that's technically positive 1. So when I multiply through by that negative 1, I'm going to let it cancel this one out here, so I end up with x to the fourth plus 1 over 2x to the fifth. And this one does match this one, which means we do have origin symmetry because for every xy, there is negative x, negative y. Okay? All right, so that's your symmetry. The next page is going to be even and odd. So it says algebraically test to see if the given function is even, odd, or neither. So remember for this, we're not making any assumptions ahead of time. What we do is we find f of negative x, well in this case n of negative x, and see how that works. Remember that if f of negative x equals f of x, that means it is an even function. If f of negative x equals negative f of x, then that makes it an odd function. Okay, and if neither one of those is true, then it's neither one of them. So I just got to plug in the negative x. In this case, we're using n. So n of negative x equals 1 over negative x squared minus 7, which means that n of negative x equals 1 over x squared minus 7. So now I look at n of x, I look at n of negative x, they are the same. So since n of negative x equals n of x, this is an even function. Remember, you want to pause, try it out yourself, and then watch. Don't just let me work them for you. Same thing here. We're going to look, we got to plug in, so pause if you need to, write this down, try it out. Then j of negative x is equal to 4 over negative x minus 5. So then I simplify this, or actually, I'm sorry, well, it kind of is simplified. I can't really do anything else. So I just look at j of x, and I look at j of negative x. They are not the same. So since they're not the same, I know it's not even, but now I've got to factor out my negative 1. So j of negative x equals negative 1 times, and then I could change the numerator, but I got some signs going on down here, so we'll leave the numerator as 4. When I factor out the negative 1, this gives me x plus 5. So now I look at j of x, and negative j of x, and that's not negative j of x. So that tells me that j of negative x does not equal j of x, and j of negative x does not equal negative j of x. So this is neither odd nor even. It's neither one of them. Okay. All right. So the last one. Pause it. Think through it yourself. Then start it back up. Okay, so I've got to find h of negative x. That's equal to 3 over negative x. Can't really simplify that anymore, so I look at this. This is not the same as h of x, so I know it's not even. So then I find h of h of negative x. I'm going to factor out my negative 1. When I do that, that gives me 3 over x. So then when I look at it, this right here is h of x, which means this is h of negative x. So since h of negative x equals negative h of x, this is an odd function. There you go.